With parts getting more complex, you need a CAM system that can grow with you as a business. So we've come to Weymouth, to IML, to find out how they're using hyperMILL. Now David, we've travelled all the way down to sunny Weymouth, had a nice walk on the pier, which was great, but to visit you here at IML, and you have a really nice shop, and I do like your logo, by the way. I mentioned that to Joe. So can you give us a background into you and IML? Where did you start?
30 years ago now. Myself and my partner Jerry Way started the business up 30 years. We've been in partnership for now, and it's slowly evolved into where we are now. We're a subcontract manufacturing company. Our customers are pretty wide. We do pretty much all the sort of sectors, mostly in the automotive now. We've seemed to have got ourselves a bit of a name in the hypercar industry. So we're making quite a few parts for those nice cars, the ones we can never afford to drive.
That's it. Next time we come, you'll have one parked outside.
I doubt it, no.
Now, David, we've got some really nice, fancy-looking parts here. So what are these for? What customer are they for, if you're allowed to say it? And you're machining these from solid, so obviously that must take quite a lot of programming.
Yeah, these are all automotive parts at the moment. You can see there's wishbones and knuckles and such things, and they all come machined from solid. And they do take quite a bit, but as I say, hyperMILL takes the strain out of that. You know, as a complex part, you know, the bigger it gets, the more complex, it doesn't necessarily get harder to program. You know, sometimes a little small intricate part is just as hard to program as a large one. You know, it just takes longer to do. There's a lot more material to remove. I think this part here started off at 200 kilos as a piece of raw material and ended up at 7 when it's finished. So there's a lot of material to remove out of that, you know. So yeah, things have moved on, but they haven't moved on.
Now, I like what you said there, that obviously parts get bigger, they get more complex. Now, that brings quite a big problem, and that's on regenerating programs. If you need to change the way the machine moves from hole to hole, let's say, you don't want to have to regenerate that entire program because it's going to take you a long time. So how has hyperMILL helped you actually make these parts, let's say, quicker or make changes quicker?
Just simple that we mentioned before, it's just a little regeneration. So we can just regenerate one tool instead of having to regenerate the whole program. You know, once the parts on the machine, it's really hard to see what's going on with the cycle paths on the screen. But when you've actually got it on the machine, you can see if it's making mistakes, if it's cutting thin air, or if it keeps going up and over, which a lot of the software packages do. So we can go back to that part of the program and just change it and make sure it does all the machining on this side before it goes over, so it's not keeping going over the top. And we can just change it, and we can just generate that one little part of the program, which means we can get the machine going again quicker.
And obviously, doesn't that surely helping your cycle times as well?
Oh yeah, without a doubt, yeah. I mean, obviously we don't have any programming offline. Everybody that programs here using the software works the machine as well. So they will come out once they've wrote a program, put it on the machine, and they will watch it go round. And the first thing they do is how we can reduce this cycle time, which different tool paths we can use. Is it going up and over all the time? You know, what we call cut and thin air. Is it try and take out all of those sort of things, and you will then reduce that program down until you're completely happy with it, and we save it, stored it, and it will just carry on running each time we make that part.
We're in Weymouth here, so we're quite far away from headquarters, let's say. So what happens if you've got a problem? How fast can you get that rectified?
Pretty quick, you know, with the help of teams. You know, all the software packages are now linked up with, you know, with hyperMILL as well, so they can have a look at our screen, see what we're doing. We can send them the model, they can have a little look at it, we can send them the program, and they can say, look, try this path or that path. You know, it's been a great help moving from one to the other. hyperMILL's got a few more different paths they can use, so we need that little bit of help along the way. The transition was fine, it's just keeping on top of it now. Every get is evolving all the time, so when the latest toolpath comes out, you know, it's nice to speak to someone, they can tell us how much that is an improvement, you know, and then we can go back to programs as well, which we've done before, and put a new cycle path onto it as well, and then try and increase it from last time.
And one part I just want to know a little bit more on as well is you've got quite a lot of machines here, from 3-axis to 5-axis to lathes. So what happens if you're running a part on, say, a 5-axis machine and then want to move that onto the 3-axis machine? How hard is that to reprogram? Do you have to reprogram the whole thing, or can you just alter it?
No, once you know, each program has a tool, so we can just take certain tools out, or we can just take the program, put it through a different post and put it onto a 3-axis or a 4-axis or a smaller, you know, we go from 350mm up to 850mm. So, you know, it doesn't really matter to us. Once we've got the basics in there, once we've got each tool in there, we can either take those tools out, if you know, if we don't want to do it on a 5 axis, put it on a 3 axis, or we can change it around and come from a different direction if it's going to go on a horizontal. So, you know, so once you've got the bones of the program, all the tools are programmed on it, we can then jiggle them around, put them through a different post, no problem whatsoever.
And I like how you're programming parts while it's running so the machine never stops, and that goes for lights out as well.
Yeah, I mean, obviously machines are not cheap now, you know, so you have to take that money that machine costs you, if you divide it by the 40 hours in a week, it's a lot of money. But then if you work 24 hours a day, 7 days a week with automation, then you can take that hourly rate or that cost of that machine and divide it by 24/7. And that machine then works out a lot cheaper to run, which we can then pass on to the customer. We try not to let these machines stop at all. You know, the automation helps that a lot. I think every machine that we've got automation on runs at about 97% capacity. Whereas the old-fashioned 3-axis machines we've got, where the bloke's got to stand in front of a machine, they run at about 67% capacity. So you can see the advantages of having automation. We're also very lucky with the mix of work we've got. We've got lots of small batch work and big batch work. So we try and run the big batch work over the weekends and in the evenings. And then during the day, when we've got more staff here, we try and run the small batch and the prototypes through. And that's when hyperMILL comes into its own there, because we need those programs going through quick in order, you know, when we're trying to make them during the day.
So, final question, and answer this how you like. So, it's been really positive by the sound of it, moving to hyperMILL, and obviously at the moment you're still running 2 CAM software side by side, but as time moves on, are you slowly moving more into just using hyperMILL? Obviously there will always be a place for your other system, you've had it for 25 years, but more and more you'll move to running more and more parts through hyperMILL.
Yeah, I don't think that's a decision we're making as a company. That's a decision that's made by our customers. Parts are getting more complex, so the more parts are getting complex, the bigger they're getting as well. That means naturally we're having to move hyperMILL, because hyperMILL is better with the higher complex parts, the bigger parts. It's quicker to program, quicker to regenerate, so we're naturally having to move that way to hyperMILL. It's not a conscious decision we've made, it's a decision that we've had to make because that's just the way that our components are going.